So I want to thank the Democracy Fund for sponsoring this series of webinars. This is one in a series of webinars that they have sponsored on the common data formats, helping election officials and vendors understand what it takes to implement them and where they can be used in the elections ecosystem. So this webinar is going to be about validating your common data format implementation. That's particularly important when we're talking about interoperability, because for two systems to talk to each other, they have to have the exact same understanding of elements and words and data structures as their partner. And thankfully, there are ways to do that using XML and JSON technologies. So today we're going to focus on XML techniques. Like I said, my name is John Gerlai. I've been working on the common data formats since 2012, back when I worked for the Ohio Secretary of State's office. Since 2017, I've been working with NIST and the EAC through the working groups that they established on interoperability to get the common data formats out the door. We now have 4 common data formats that cover areas such as cast vote records, election results reporting, event logging, and voter records interchange. Sure.
And I'm Sarah Witt. I worked in Wisconsin elections for about 15 years, and then I spent the last 2 years working for Eric. I also joined the CDF project, way back probably around 2012 when it was still under IEEE. And election results reporting was really the first standard that we really actively pushed for quite a while. And I was working group chair for that working group way back when, and I see a couple of my fellow working group members are on this call as well. So it's wonderful to see you guys, and it's been a long journey. Happy to be here.
So hopefully you know what a common data format is, but in case you don't, common data format is something that we've seen the need for in this space since the mid-2000s, and early efforts were underway probably as early as 2005 to develop a common data format. It's been a long road, as you can tell by the length of our participation in that, but we really see the value in it. And being election officials, we know firsthand the difficulties of dealing with systems that don't talk to each other very well. That's particularly true of the boundaries between systems such as voter registration databases and election management systems, or electronic poll books and voter registration databases. Those systems each have their own format, and mapping between them is an arduous task, and it's a moving target. So the NIST came up with the idea that we would form working groups to develop common data formats that covered most of the use cases that election officials were looking for, which I already discussed. The first one came out in 2016. That was election results reporting. And since that time, the Voting Information Project has used a lot of the concepts in the common data format in their own format, such that it's very easy to map between VIP and the election results reporting CDF.
Okay, so what we're doing in Wisconsin with the CDFs, I'm personally extremely excited about. Working on this webinar, I started thinking back to why I joined the common data format effort in the first place. And I'm going to give a quick shout out to Ann Oberly in Wisconsin, because she and I had this beautiful dream that probably goes back to when we were implementing the statewide voter registration system in 2005 and 2006, which was really this glorious idea that if you're going to put all of your pre-election information into the statewide voter registration system. In Wisconsin, we put in full ballot information. So we have candidates and contests and ballot order and all that kind of stuff. So then the question was, shouldn't we be able to export this and then use it for programming the voting equipment to save data entry? And then when the election is done and we need to recollect all of the vote count so that we can do certification, we should be able to just link all this stuff up and it'll be great. So here it is, 2021, and we're still working on this glorious dream. We call it the circle of life. And what the pre-election election results reporting file allows us to do is another one of my beautiful dreams, which is build one file and give it to everybody. So when VIP aligned its schema along with the common data format, the first thing we did was try to work on how do we generate a file in the 1500-100 format that we can then give to VIP. And bless their hearts, they've been taking that file for quite a while now. We gave it to the Associated Press to see if they could suck it in to help build their initial database. So this circle of life was really the next logical step. If we already have this file built, why can't we try and do a pilot with voting system vendors? And ES&S, thanks in large part to Herb Deutsch, fellow working group member, agreed to help us try to figure out how to make this work. But that's the basic concept. There are certainly some challenges. We talked to other states who have tried to do this before, including Michigan. I think some of your guys are on this call as well. So, but it is, as you can see, harder than it sounds. Some of which John highlighted here. Geopolitical geography, always interesting to map together. We're going to talk about that in a little bit. Determining what to include and exclude has also been pretty interesting. How you want to scope this matters a lot for how successful you're going to be. Statewide files for VIP versus now doing like one county at a time. That was, it was an interesting translation there. So, but ultimately, the voter registration system does have to map back to the common data format. And by that, I mean all of the different objects in the common data format largely match things that are probably in your voter database anyway. So one of the things we tried to do with the CDF was have it match reality so that this wouldn't be quite such a heavy lift. Okay, John, you can go to the next slide.
Okay, so we're going to talk about validation. And one thing that comes up, and we're actually going to get into more detail about this, is that the common data formats can serve a whole host of use cases. The election results reporting common data format, despite its name, can do pre-election exports, and that's been the primary use for it. But even within that use case, Wisconsin has used it for feeding VIP, for providing pre-election data to the Associated Press, as well as the pilot we've been doing with the jurisdictions to preload data into their voting system, EMS. So when you have all these different use cases, the things you're going to need in those files is going to be a little bit different, and how to validate that is going to need to be customized for each use case. So the common data formats, if you read the specification, you can get the gist of what they say. They talk about the names of things. They tell you a little bit about those things, give you a description. There's ordering in each class regarding what order things are supposed to appear in the file, how many times those things can occur, and the data type. You know, can it be a string? Is it a number or an enumeration, something else? So that's a lot of things to track. And certainly you could open up a XML or JSON file and say, okay, I can see that this is conformant or it's not conformant. But these files get very big very fast, and you're not going to want to validate them by hand. So thankfully, NIST doesn't just provide you with a narrative document, the CDF specifications, but also something called a schema, which describes in a machine-readable way the form or shape that the data is expected to conform to. There are things called schema validators, which ensure that your instance file conforms to the shape of that schema. And like I said, each CDF includes two schemas, one for the XML serialization and one for the JSON format. So the benefits of schema validation is a baseline level of assurance. You know, trust but verify. This is the verify. So you might think you're the world's greatest developer, DBA, whatever, and you may be, but why don't we validate that using a tool? You don't want your downstream consumers having to do that validation for you. So it provides the producer with a confidence in what they are providing, and it also provides the consumer in confidence that what they're receiving isn't junk, and that the assumptions they make about the file can hold true. Additionally, validation is very low overhead. It can be done even with very large files in an efficient way. And that brings us to our first demo. So hopefully everybody can see this okay. You might have to make your screen a little bit bigger. This is a tool called XML Spy, and what I have up right now is a file from the Spring Primary in Dane County. And I've introduced errors into the file because it's not terribly interesting to run validation and then see that it just says, congratulations, the file's good. So don't worry, the file is good. I just added some things for demonstration purposes. So when you load up a XML file, there's a bunch of attributes at the top. One of those is something called the schema location, and if you specify that to a path either in your file system or something on the internet, maybe the GitHub repository for the CDFs, it will load in the information about the schema, and you can use that to validate the file. So I can do kind of two forms of validation. One is just kind of a textual analysis that it is valid XML. So if I click that, it just says at the bottom here, the file is well formed. And what's that testing for? It's testing for if you put in something that's not semantic XML. So if I put in just a open bracket, close bracket, it's going to throw an error. Now to do a more thorough syntactic check, we'll run the schema validation. And it found a couple errors. The first error is that the generated date needs to have a time segment added to it. So I'll just set this to midnight UTC. You see that the squiggles went away. And then if I run validation again, there's one more error here where it says that polling location is not allowed for this element. Well, this is a GP unit, which is a polling location. In fact, you can see up here a comment that says this is a polling location. We're just using the wrong enumeration, and this tool will actually give us a list of valid values we can put in this. So we're going to select polling place. And now if we hit validate again, it will say, hey, congratulations, the file is valid. Of course, this is not the only tool you can use to do validation. There are tools available on the internet free of charge, even come with Windows that can do this kind of validation. So just a little bit on terminology. The word instance gets bandied about, and what that's referring to is a file, either XML or JSON, that's conformant to some schema. So when we talk about instances, We're talking about something that conforms to one of the common data format schemas. Now we're going to get into subset schemas. So like I said earlier, there's all these different use cases, right? And this word diagram shows all the different terms that are used in the various common data formats. And there's quite a number of them. And determining what you need in a given common data format exchange is not trivial. If you look at the properties in the common data format, there's quite a number. In fact, in election results reporting, there's 207 properties. But 161 of those properties are optional. So what this ends up meaning is that we need to specify in greater detail what we need for a given exchange. The example I like to give out is that we support pre-election and election use cases in the election results reporting CDF. Well, pre-election, you're not going to have counts in the file. So how does it validate without counts in the file? Well, it's optional. What we have to do then in a election or post-election use case is say counts are required. And a subset schema allows us to do that. Sarah?
Yeah, so really the beauty of this, we've heard from some people, particularly when we were first working on this, that seeing the high number of optional properties, people were afraid that it would be hard for people to then consume these files if we made so many things optional. But as a state like Wisconsin, you know, we have uniquenesses in our rules and the way our data presents that are different from other states that may be trying to do something very similar. When we were working on the format, we started working with Florida, for example. I think Janet from Florida is on the call and will remember this. Business rules from Florida are not necessarily the same as business rules from Wisconsin, as I'm sure we can all attest to that. Not to mention this statewide export versus a county export, or a state export that's designed for publishing data out to VIP or the Associated Press versus, well, now we have a county-specific file that needs to be able to be consumed by a voting equipment system that has very specific requirements. So really, as the implementer, you need to think about what you need in your file. So I have quite a few of these optional properties that I deemed to be quote unquote required because they were required based on my state business rules and based on what we're trying to implement. So overall, every state can use this same format, but within these optional properties, many of them are not actually, in fact, going to be optional. You can go to the next slide.
So what do we do then? What we can do is profile what we need in the common data format. So a profile would be a subset of the common data format that applies to our data exchange needs. And the profiling that I'm going to show you is called XML profiling or XML redefinition. And there are certain things that you can do and not do in profiling. So you can make optional items required. There's a lot of optional items. You can disallow optional items in the case that you don't want something in your file, but you can't make something optional that was originally required in the common data format because that would break interoperability. And of course, you can't add new structures to the CDF either because that would also break interoperability. You have to work off the extension structures that are built into the CDF. Sir?
All right. So as you've probably heard throughout this presentation, in order to do this successfully, you do really have to have good documentation. Some of us get very excited about documentation. Some of you maybe not so much. But so we started in our project in Wisconsin with written documentation, basically because as a starting point, for me working on this, I am more of a business analyst and less of a hardcore technologist. So I needed a way to understand the CDF in normal words, you know. So kind of what we stated here, there's many ways to write down what you actually need to do with the CDF. There's really kind of 3 levels of documentation that we tried to do. First of all, we have structural documentation, which is really going through what all of the CDF are we going to use. What is it that we have in our VRDB that can be put into a CDF file? So I kind of had a big list of here's all the classes we're going to use. And then how are we going to glue those together? The schema itself has rules about what can be attached to what, and you need to know that in order to actually build out the file. Kind of the second tier of documentation is then how do I pull this stuff out of my VRDB and put it into this structure that we built for the NIST schema. And then kind of the last tier are what are the general business rules that govern this data that sort of explain how this data should work, what things should go together and what things shouldn't. You know, should every precinct have a polling place? Yeah, probably. You know, but you need to know those kinds of things ahead of time in order to know how to write your schema itself, as well as then how to validate it. So my personal favorite, as many of you will know, is Excel. I have this gigantic Excel spreadsheet with all these different tabs to kind of articulate a lot of these concepts. But then ultimately, we were able to hand this off to John as a contractor, and he was able to use that documentation to build the file. So you can talk a little bit about the subset schemas, John.
So yeah, like I said earlier, subset schema is a native feature of XML. It does require good XML skills or a tool. Really, you'll want to use a tool, and I will be demoing that in just a couple slides. So the good news about a subset schema is you don't have to restate everything that you want to keep the same. So if you're only changing one item, you're going to have a very tiny subset schema. But because of the way it works, anything that doesn't change kind of just passes through. You can kind of view the subset as a transparency layer, and you're just mocking up on top of what's already there. And now to the demo. So we're going to use our friend XML Spy again. And I'm going to bring up a subset schema. And this was a schema we developed for the pre-election use case in Wisconsin. So Sarah did all this really good documentation describing in prose how to pull things, what's required, what we don't want in the file, etc. And then I mapped that onto the subset schema. So I'm not going to go into great details on how to use the tool, but suffice it to say, the items that you're seeing here are classes or types in the XML schema. And those are things that exist in the CDF, like contests, elections, candidates, parties, etc. And anything you want to override, you basically put in this list. So if we go to party, for example, you'll see that we have this kind of like tree-like structure. But what's unique about this is the fact that we can specify whether we want things to be required or to be optional or to be disallowed. So this item at the top here is actually required. So we set the cardinality, or like the minimum number required, to 1. So we're saying we want abbreviations for every party. And then these items that are hashed out are things we said we didn't want. And if we click this button here, we can kind of toggle between those states. So this would be kind of the default state. And we hit the little X, then it's saying this is disallowed. So that's an example here for one of the classes in the CDF. if we actually look at a file, and I'm using a file from Dane County again, if we validate this file, it throws an error. And if we look at what it's throwing an error about, we say, okay, external identifier, that's allowed in the CDF. But in the subset schema, we've said we're not allowing external identifiers. And this is actually something we added to round-trip data back and forth between the state system and the county system. Sarah, do you want to say anything about that?
No, I think you summed it up well.
Okay. So we actually need to change our documentation. So this is kind of an example of when documentation gets out of date, you know, your subset schema can get out of date. So we decided we needed to pass these identifiers back and forth between the vendor system and the state system. So all we need to do is go to the class, I believe it was candidate contest, and you'll see this is hashed out, and we just say, make it allowed, and now if we validate, it is valid.
Okay,
and of course we could do it
with the external identifiers. If any of you are curious about that, what our hope is that, particularly in this use case where we're exchanging data with the voting equipment vendor, if we can keep track of all these different objects, when we get the election results coming back in, our idea was that if the vendor can pass through these identifiers, we'll be able to suck them in later, and it should, in theory, make our canvassing import a little bit easier. So we actually went through what are the data elements in the Canvas system that would help us to be able to tie a results file back to the actual data elements that we already have in our database. And that was really how we figured out which all places we wanted to add these external identifiers. And basically it was just a way that we can stick in, you know, like a database key or some kind of code from the VR system, so that by the time that Canvas file comes back, then when you're importing that, you can link up those IDs and then just suck the counts right into those buckets without it being quite as painful as it is right now. All right, John, you can go on now.
Well, and I think that's all there is to really say about the subset schemas. There is a white paper on my GitHub repository, and I'll include that along with a copy of the recording after this webinar. So our last topic is Schematron rule sets. And you might think, well, what else is there to talk about? We've talked about validating against the common data format, validating against subsets of the common data format. What could possibly be left to talk about? Well, there's these things called business rules, and everybody's got them, and most people have got a lot of them. And there's got to be a way to express things beyond just the simple, this is required, this is optional, this is disallowed. Things like if-then logic. So if I have this data item, then maybe something else needs to be set to a particular value. Or mutual exclusion. I want one thing or the other, but not both.
Okay, so I'm a big fan of the Schematron rules because of the complexity of the business rules that we have in Wisconsin. So probably one of the biggest and most complex portions of our file is how you link together all the different geopolitical units. So in the election results reporting format, there's this thing called a geopolitical unit, which really can be kind of anything that represents some sort of physical geography. So we have, well, in Wisconsin, for example, we have, I would say, at least 17 district types. Ann can correct me later if I'm wrong, but there's a lot of different election districts in play, as many of you know. So if you have those districts on the ballot, you need to be able to represent those in the file, but you also need to be able to relate those districts then back to the precincts that you're going to report results at, and the polling places where people are going to go vote. And of course, in Wisconsin, we also allow combining of precincts within an election. So in a given election, what your set of precincts are may be slightly different than the previous election. So in our case, those combined precincts became very important because that's ultimately what the buckets are that results are going to be provided in. So when it comes to gluing all these things together, some of them make pretty obvious sense. Like I said, a precinct probably has a polling place. But how you relate, say, a polling place back to an electoral district, that's much more complicated, and it depends on what ballot is at that polling place. So we actually reached out to one of the larger users of this format, which is Google, because they're using it to report election results internationally. So we asked them how they go about gluing all these things together. And at the time, the advice they gave us, which is what we ultimately ended up doing, is to take the smallest building block, which in our case is, we call it a district combo, but it's also, people call it a split precinct or a precinct split, which is basically the smallest possible unit of geography that is not divided by any other electoral district of some kind or other. So we just use that tiny building block to build up everything. So if you want to know what's in a combined precinct, it's composed of a bunch of district combos, and each electoral district is composed of that, as well as polling places. So that allows you then to sort of take down and rebuild those tiny little blocks in order to get our actual geographic areas. And then new this year, thanks to the help of the Wisconsin team, we were able to add in early voting locations as well as drop boxes, which were supported for the November election that we were able then to provide to VIP. Again, just gluing them in the same way. And once you've set that up, it's actually not that hard. John can laugh at me for saying that. It was actually kind of hard. But it's not actually that hard then to add in new geopolitical units if you want. And maybe you don't consider a drop box as a geopolitical unit, but there is an area of voters that can use that drop box. And in my case, my city set up several drop boxes. So basically the geography of my city is who is eligible to use those drop boxes. Also, one other thing I'll add in this quickly too, then working on the county-based file for ES&S to be able to import. I'm pretty sure we have Rachel from Dane County on, who was our extremely gracious guinea pig as we first started working on this. One of the things that we learned as well is that the requirements you have for importing into voting equipment are not necessarily the same as we had before. So we had to, rethink some things and make sure that then our county file supports the rules that we need in order to make that import work as well. So every time you expand your use of the common data format, there is kind of a deliberative process, and we've definitely been learning as we go. But the beauty of these validations, and the reason why we're having this webinar at all, is because once you've done that work and you've figured that out, these are the tools to help you make sure you're doing it correctly. So you can go to the next slide, Jen.
Thanks, Sarah. So Schematron has been called the feathered duster for XML. So it is going to reach places that the other tools don't. And like I said, what a schema can't tell you is whether or not your business rules have been correctly accommodated in the common data format. Hilton Roscoe provides a couple baseline rule sets, one for the cast vote records common data format and one for election results reporting. That really talks to rules that apply across all use cases, so things that would have to be universally true. So I would recommend you check those out. Again, I'll send you links to those at the conclusion of this webinar. Of course, what we've done is we've extended that with our own rules for our own use cases. And this provides probably one of the highest levels of assurance that our files are correct. And before we were doing this, I mean, we introduced the Schematron rules probably last year, maybe the year before. But before that, Sarah and I would look at the file, I would do some XPath queries and say, okay, this looks like it's wired correctly, and Sarah would look at various parts of the file. But it was a spot check, and these files kept growing and growing. And I thought, you know, this is taking a lot of time. Maybe I should automate this. So these can save you time. I mean, these techniques, they do take a little bit to learn, but really they're all complementary skill sets. And now to the demo. So once again, Dane County, our guinea pig for everything, is going to be used to great effect. And again, I've introduced errors into the file for demonstration purposes. This tool is called Oxygen, and it has a very good Schematron support. Schematron is a industry standard, however, so you can use any tool that understands Schematron, and in fact, I show you how to use some of those freely available tools in the white papers that I'll be providing to you. But this is a particularly slick tool that really gives you a lot of value add. So what I'm going to do is I'm going to run one of these two Schematron files against the Dane County file. So this is very similar to schema validation. So I'm going to run this one first. This one is actually a subset of the baseline that we provide to everybody. So some of these rules didn't apply to us and we took them out, but this is really just a subset of the baseline you could download off the GitHub repository. So if we look down here, you'll see that there are a number of errors, and they're actually grouped. So there are severities that you can give various types of issues with your file. I think there's informational, warnings, errors, and maybe fatal, and they all color code different. So it's kind of nice to do that just so you can really prioritize what's important versus what might be something that might affect one of your use cases, but not all of them. This top one is an error, however, and what it's talking about here is this Office IDs element. I scroll down and find it. Where are you, Office IDs? Here it is. Office IDs does not point to the type Office. And that has to do with these things called IDs and ID refs in XML. Basically, an ID is an ID, and they can point to different things, but you can't know at the XML schema level if they're pointing to the right thing. So what these baseline rules do is they validate that Office IDs point to offices and that person IDs point to people because the IDs are otherwise opaque. In this case, to generate an error, I had Office IDs point to a person type, and actually we prefix all of our IDs with various prefixes that Google came up with. So persons start with PER and offices start with OFF. So kind of a trivial example here, but this will allow you to validate very quickly your wiring of your file. That's something that once you get a hang of your export, you're probably not going to run into those errors again because they're not data related errors. They're actually related to how you're exporting your data. But this is something very nice to do when you're developing your file. Oops, what did I do? Oh, so I'm going to comment out the one with the error, and I'm going to uncomment the one that's good. I'm going to rerun the validation. Now we've got two other errors. And these are a little bit more interesting. You remember I said some of these errors didn't apply to us. And the reason why they didn't apply is this class of errors that it's catching, in this case, has to do with basically dangling objects. So let's say I have a candidate. I define a bunch of candidates. And a number of those candidates aren't used by any contest selection. So basically they're just dangling out there. It will throw a warning saying, hey, why does this object not point, why isn't that not being used anywhere in the file? So in this case, it's saying, hey, we noticed that you spit out a Constitution Party as well as a Libertarian Party, but we don't see you using those objects anywhere. And one nice thing about Schematron is you can develop these things called quick fixes. So you'll see there's a little light bulb here, and if I actually click that, I can delete this. So I can actually fix my file directly in the editor, assuming that I don't need or want that party in there. So the rules that we edited out of the file because they weren't applicable to us had to do with GP units. And Wisconsin's got a lot of GP units. You know, you have split precincts, you have combined precincts, you have quite a number. And for our VIP use case, we needed to provide some GP units that actually weren't used anywhere else in the file. For example, Dropboxes. Dropboxes are something that we introduced in 2020, but aren't actually wired to anything else in the file. There's no contest that's associated district is a Dropbox. So it would throw a warning saying, hey, this isn't being used anywhere, but we actually were intending to pass it down to the consumers. Sarah, is there anything you want to say about any of that?
Well, there are certain types of GP units that you don't want orphaned, though, like, for example, a district combo. So knowing what your rules are and thinking about these rules ahead of time really helps make it go, makes this go faster and really makes this an extremely powerful tool because you're able to identify things that you could never see eyeballing in the file. And you can, I hate to say it, but I'm sure we've all experienced this. You will find problems in your database, in your VRDB that you didn't realize were there necessarily. That's the beauty of having to put your data in a structured format, is that you may find things that aren't necessarily correct.
Yeah, I mean, the value add with the Schematron rules is you kind of set them and forget them. You know, there's validations that you do every time if you're very, very conscientious, but eventually we run out of time and we skip steps and quality suffers. So this keeps our quality level very high between the consumer and producer.
Well, and some of these warning rules are really nice too. So for example, in Wisconsin, we have partisan elections and we have nonpartisan elections. So you wouldn't necessarily expect to have a party associated to a contest in a nonpartisan election. Or, for example, in a general election where you have parties running against each other where the contest itself is nonpartisan, but the individual candidates are. So we build a rule to look for a party associated to a contest if it's not a partisan primary. Well, as we all know, there's the exceptions. So this upcoming February election that's happening next week in Wisconsin is a quote-unquote nonpartisan election, but of course it has a special partisan primary attached to it to fill vacancy for a partisan office. So here you have a nonpartisan election where we're supposed to have contests with parties, So that's where these warnings are kind of nice, because you might get a warning and you're like, oh, okay, well, for this election, that's okay. But if you're in the general election and suddenly there's a contest on the party, you really don't want to be showing that your contest for candidates from multiple parties, suddenly the contest is supposed to have a party that looks bad, right? So there's a lot of interesting things you can do with this, and you will possibly write rules and then realize later that the rules are more complicated than what you wrote, because the one true thing we know about elections is that it always works this way, except when it doesn't.
So I just ran the validation after deleting those two parties, and it said, good job, validation successful. But I'm going to now run the custom rules that we built for Wisconsin. And something we did in addition to building these rules was to break them down into kind of subsets. Because like I said earlier, we've got all of these different use cases. And we built these rules for VIP around making sure that everybody got a Dropbox. Every district combo had a Dropbox associated with it. And that was fine for the query that we were running for VIP. But what would happen, in fact, I can do that now, is if we run this for the Dane County file, there's a bunch that don't have associated early polling places or Dropboxes. And that's totally fine for the use case that we're doing for pre-election data between the voter registration system and the EMS. So I didn't want to see all these errors. And I thought, okay, well, maybe I could split up the file, but that becomes a lot to manage. Actually, the Schematron people have thought ahead, and you can actually break up your rules into what they call phases. And I built 3 phases. So there's one for our statewide file, which includes everything from the main phase as well as those rules that would be applicable to the drop boxes and early polling places. And then I created one called vendor ESS for ES&S that excludes those rules. So I'm going to run that one. And it actually does throw some errors about GP units, but like I said, these have been introduced. And what it's saying is, hey, you've got split precincts. They're not covered by any polling place. So it's checking that wiring again. But in this case, it's checking the wiring that's specific to how we built the 1500-100 file. I think that's most of the errors. Go ahead.
Yeah, these kind of validations are super useful for us. So Wisconsin has a lot of local jurisdictions. We have 1,851, 50, 52, somewhere in there, municipalities that all have to put in their election information into the VR system. And you will see cases where things are in flux as they're getting ready to set up for the election. That's the fun of a pre-election file, is this data could be changing. So you might run the file and get some of these errors. Well, then I can send those back to the Wisconsin team and they can go contact that locality and they'll find out, oh yeah, we moved the polling place. And so now they just have to put the new polling place in. We also had an interesting, fun experience, I'm going to say more than once, where we had an annexation close to the election and it required creating a new precinct. So the new precincts were in there from literally like almost the same time we pulled the file, and they hadn't yet been set up because the annexation was so recent. So these are the kinds of real life circumstances you're going to run into. The best job that all of your localities do to update their data, you're still going to find these goofy things. So, I mean, we've never run a file yet where we haven't, at least at the state level, where we haven't had to go back and ask a few questions. The county files have been a little bit easier, but also in part due to the diligence of our county partners that are working on this pilot with us, Rachel. So we appreciate that. I may have already said all the things I was gonna say about this one. Well,
good. More time for questions.
I know. While you were demonstrating, I got a little excited. But definitely I found the Schematron rules to be very helpful. You know, Wisconsin has a very active data quality team that works with the locals to help make sure that the data in the statewide voter registration system is correct. It's the same data that gets published on our My Vote Wisconsin website where clerks can, or where voters can go and look up this information. So it's obviously a high priority that everybody be working from the same information. And so those rule sets have been kind of an extra layer of data quality that we can add on top. But like I said, sometimes you find out that issues are with timing. Like it's very difficult to pull a file right after a bunch of annexations get loaded into the system. So, but this is, again, the better job you do thinking about your rules ahead of time and writing them down will make these a little easier to set up in the first place. But then you also have to be flexible when you realize that some of the rules you wrote maybe aren't so good, which, you know, I would never admit that my rules aren't perfect, but many others would prove that otherwise. So, you know, the flexibility of this makes it quite helpful. We've added rules. I don't know, I feel like every new election type, Herb Deutsch mentioned this, when you're dealing with the vendor import, each new election type brings its new and interesting challenges. And I feel like we add new validations after every election